Imagine the Earth's surface slowly tearing apart like a zipper being pulled open. But instead of fabric, it's the very bones of our planet. This is what's happening in East Africa, where a hidden force deep beneath the ground is rewriting the geological story of our world. But here's where it gets controversial. Could this natural process, unfolding over millions of years, hold clues to predicting catastrophic volcanic events or even reshape how we understand Earth's history? Let's dive into the science behind this seismic drama. Deep within the Earth's mantle, a layer of semi-molten rock sandwiched between the crust and the core, heat builds up in rhythmic pulses. These pulses drive massive upwellings of material, much like convection currents in a pot of soup. Scientists call this a mantle upwelling, and it's a key player in creating volcanoes, splitting continents, and birthing new oceans. Nowhere is this more evident than in the Afar depression of East Africa, a region where three tectonic plates are pulling apart like fingers on a glove. This triple junction, where the main Ethiopian rift, Red Sea Rift, and Gulf of Aden Rift meet, is a geological hotspot, and for good reason. For decades, researchers suspected a massive mantle plume was fueling the region's volcanic activity and frequent quakes. But the details of the subterranean engine remained a mystery, until now. A groundbreaking study led by the University of Southampton has finally mapped the structure of this plume, using lava samples from over 130 volcanoes. The findings? The mantle beneath Afar isn't a simple uniform column of heat. Instead, it's a chaotic mosaic of plumes and varying materials, more like a patchwork quilt than a single stream. It pulses with distinct chemical signatures, explains Emma Watts, the study's lead author, who now works at Swansea University. These molten pulses are channeled by the rifting plates above, accelerating the continent's split. And this is the part most people miss. The mantle's behavior isn't static. It changes depending on the tectonic activity above. In fast-moving rift zones like the Red Sea, the mantle flow is focused and powerful, while in slower regions, it spreads out more gradually. Tom Gernon, a co-author from Southampton, likens this to a cardiovascular rhythm. The chemical striping suggests the plume is pulsing like a heartbeat. These pulses behave differently, based on the thickness of the plate and how quickly it's stretching. This dynamic interplay has far-reaching consequences. The upwelling is eroding the lithosphere, the Earth's rigid outer shell, thinning it to just 15 kilometers in some areas. Combined with the stretching plates, this thinning triggers volcanic eruptions and seismic swarms, with lava flows covering vast stretches of Ethiopia. Over millions of years, researchers predict seawater will flood the rift, splitting the Horn of Africa from the mainland, in a geological replay of how the Atlantic Ocean formed. But the implications go beyond Africa. Similar mantle heartbeats could explain ancient volcanic eruptions and sudden climate shifts in Earth's history. For example, the North Atlantic Igneous Province, which created Northern Ireland's Giant's Causeway 60 million years ago, may have spewed so much CO2 and SO2 into the atmosphere that it triggered mass extinctions. Understanding the tempo of these deep Earth processes could help us prepare for future environmental upheavals. The study, published in Nature Geoscience, is just the beginning. Future research will map how mantle flows direct volcanic activity and how quickly these subterranean forces operate. It's like solving a puzzle without all the pieces, says Watts. You need diverse expertise to see the full picture. So, what does this mean for us? While the continent's split is a slow-motion event, it's a reminder of Earth's restless nature. The next time you feel an earthquake or see a volcanic eruption, remember, it's not just chaos. It's the planet's heartbeat, slowly reshaping the world beneath our feet. Do you think we should be more concerned about these deep Earth processes? Or is it just a fascinating glimpse into our planet's long-term evolution? Share your thoughts in the comments below.